In this question we are asked to find out what is the resonant frequency of the given circuit. So we have a circuit which consists of R, L and C, and we have to find out its resonant frequency. How we can accomplish it? Now let's say the impedance of this network is of the form R plus Jx. Okay. So at resonance, what happens? This reactive part should tend to 0 so that the circuit become purely resistive. So that is the condition we have to look for. You have to equate imaginary part to 0 and find out at what frequency it occurs. Now first we have to find out what is the impedance. Impedance, we have 1 ohm and 1 farad in parallel. Okay, that impedance will be, what is the impedance offered by 1 farad capacitance? It will be 1 by j omega c. What is the value of capacitance? 1 into 1 ohm divided by 1 by j omega plus 1. Okay, plus this combination is in series with 0.1 Henry inductance. What is the impedance offered by it? That will be j omega into L. L is 0.1. Now we can reduce it further. This will be 1 by 1 plus j omega plus 0.1 j omega. Now this, we can bring the imaginary part upside so that the solution will be easier. So we have 1 minus j omega by 1 plus omega square plus 0.1 j omega. That will be 1 minus j omega plus 1 plus omega square into 0.1 j omega. Now we have to equate imaginary part to 0. We have imaginary part here minus omega. Okay, we have minus omega, and here we have 0.1 omega into 1 plus omega square, equating imaginary part to 0. This we equate to 0. We have minus omega plus 0.1 omega plus 0.1 omega cube equal to 0. This is minus 0.9 omega plus 0.1 omega cube equal to 0. That means omega cube equal to omega cube equal to 9 omega, that is omega square equal to 9, which gives omega equal to 3 radians per second. We will be taking the positive value since it is frequency. So we have found out what is omega. This is the resonant frequency of the circuit. What we have done? We have found out the impedance of the circuit and equated its imaginary part to 0 so that the impedance be purely resistive. And by equating it to 0 and solving it, we found out omega to be 3 radians per second.